Hi everybody, this is Avela. I'm from Eastern Cape. I will be presenting to you circulating ocean, or we can also say ocean circulation. Here is my outline. I will be talking about two types of ocean circulation, the wind-driven circulation, the thermohaline circulation. Also look at the interaction between the atmosphere and the ocean. Then also look at why South Africa is so special. In HPW, we want to answer this question: why is planet Earth habitable? In the hierarchy of model of HPW, we're in number 3, which is moving atmosphere and ocean. Where we also in the hierarchy of model, of course, talk about the Earth as a bedrock, where we talk about not too hot, not too cold. Second, we talk about the static atmosphere and ocean. We'll look at the light and air. Talk about the greenhouse effect. Now, look in the beginning. We look at the ocean, or at the why Earth is habitable is that it is the distance from the sun, so that it makes it habitable. But I'm not there. We'll look at the moving atmosphere and ocean, of course, moving forward. So, what is an ocean? What is an ocean? Now, what is an ocean? Now, an ocean is defined as the body of saline water which comprises of much of the planet's hydrology. As it is said, about 97% of water is in ocean, or which is on Earth is in ocean. So an ocean is a complex system which is said to be never at rest because there are a lot of currents, ocean currents, which move up and down within the ocean. So what is basically ocean circulation? Now, there are different types of definitions of ocean circulation, different people. Now, physicists, they say ocean circulation is the net of all forces acting on the ocean. Now, oceanographers also, they say ocean circulation is the large-scale movement of water on the ocean basin. Now, oceanographers, they come up with the two types of ocean circulation, which is wind-driven and thermohaline circulation. Okay. Yeah, in the picture here, this is Charles Darwin. We all know Charles Darwin, which is the father of biology. Now, Charles Darwin identified when he was doing his research in Galapagos Island, he identified that in the equatorial region there is cold water. We were expecting warm water because we know that in the equator there are high temperatures, so water should be warm, but it is not that case. Instead, it is very cold. So yeah, moving on. So that's what is all about the ocean circulation, is that differences in water density in the water. Now, there are 5 oceans. We have the Arctic Ocean, Indian Ocean, Southern Ocean, which is Atlantic Ocean, the Atlantic Ocean, and Pacific Ocean. Now, so there are different types of ocean. Now, Indian Ocean is the warm ocean. Now, let's look at the vertical structure of an ocean. Now, ocean can be divided into 3 densities. The first one is the upper surface, or the surface zone of the picnic line in the midway. We have a deep surface. Now, in the upper currents of upper surface, we have the water is very warm and saltier because the ocean is heated above, not below, unlike the atmosphere. So in the upper surface we have warm water in the upper surface because of temperatures. The water is in the ocean is warm and it is not salty. So then we have in the middle we have the picnic line, which is the barrier between the warm water and cold water. In the deep ocean, inside the ocean, deep down, you have the cold. The water is very cold and is very salty. So we know that warm water will float in above the surface, then deep water descends. That's why cold water is deeper, is under the surface. So of course here we have a lot of ocean currents. We have bigger waves, we have small waves that are happening here because of the wind. Then deep one we have the long waves. So it's where deep circulation. Okay, here we have the wind-driven circulation, but we'll learn more. So let's look at the first types of ocean circulation, which is wind-driven circulation. Now wind-driven circulation, now prevailing wind, they trigger surface circulation, which then leads to the formation of surface currents. Now due to the Coriolis effect, which is caused by the rotation of the earth, now the ocean currents deflects to the right in the northern hemisphere. In the northern hemisphere deflects to the right, then in the southern hemisphere deflects to the left. So here we look at now the blue color. The blue color here represents the cold warm current, then the red color refers to the warm current, because of differences between the warm current and the cold current. Now of course then we look at there is something what we call ocean gyres. Now ocean gyres are large systems of circulation ocean currents which are formed by global wind patterns and forces which are created by the Coriolis, by the earth rotation, which is Coriolis force. So there are 5 of them of the ocean gyres. We have the North Atlantic gyre, South Atlantic gyre, Indian Ocean gyre, then we have North Pacific gyre and South Pacific gyre. Now all these gyres, you can see that gyre, it is bounded between 2 continental masses, which is what we call gyre. So these gyres are created by the Coriolis effect. Even in the northern hemisphere, the rotation of is clockwise, but in the southern hemisphere is anti-clockwise. Now here is just the Coriolis effect. This picture shows the Coriolis effect, that the deflection of the ocean currents in the northern hemisphere is what is to the left, is to the right. The deflection is to the right, but in the southern hemisphere the deflection is to the left. Now there's also what you call upwelling. Upwelling is the importance of wind-driven circulation, which leads to upwelling, which is the process whereby the cold water will rise beneath the surface, replace the water which was pushed away. Now wind-driven circulation plays an important role in upwelling. So here this picture shows that wind will blow, pushes the water pushes water away from an area, moving backwards. So the warm water that was there will go back, will move away from the offshore. Then the deep water, with the deep cold rich water, which consists of nutrients, will rise up to go to replace the warm water which is there. Then also we call what we call the downwelling. So the importance of upwelling on biology: upwelling occurs in coastal regions, and it brings about nutrients to the water. Now, also upwelling plays a role in sustaining the fishing industry. So upwelling occurs in these regions. Now, the second types of ocean circulation is what we call thermohaline circulation, which is the largest ocean circulation pattern and is directly related to temperature and salinity, which is density. So ocean circulation, now it is also called Great Ocean Conveyor Belt. Now ocean currents move masses of waters distribute the heat. So ocean circulation is about distributing the heat within an ocean from equator to poles, from poles to equator to equatorial regions, all the stuff. So the thermohaline, which is the temperature and salinity, is also density. Here is the Great Conveyor Belt. You can see here this is the warm surface water which moved from equator to pole, then from pole goes down, is cool, surface is the cool, then goes back to warm oceans, all this stuff, but like a conveyor belt. So yeah, in the Indian Ocean, this is warm currents flows back. This process is estimated to take place about 1,000 years to complete. So the notion of ocean current or the thermohaline circulation is that the deep circulation. If you can see the color here, which is blue, which shows the deep circulation, then the red one shows the warm water, which is this upper surface. So the notion of ocean circulation is that fast, shallower circulation, and which is driven by wind. Then also the slow density driven thermohaline circulation, which is driven by salinity, which is when there is more salinity in the water, then there will be deep circulation. When there is less salinity, the water will be warm, as we can see of the Indian Ocean. Now let's talk about the interaction of the atmosphere and ocean, because they play an important role in making the planet Earth very habitable. Now ocean and atmosphere circulation is important in keeping what the planet cool or heat transfer. They both transfer heat. So in the creation of ocean currents through transfer of momentum. So that creation of the wind by oceans, so they play important role. Now ocean and atmosphere, they play a role in regulating and stabilizing our weather patterns. That is the ENSO, which is El Nino Southern Oscillation. Now the El Nino Southern Oscillation, because if you can remember, here in South Africa we have recently in 2015 we experienced the El Nino, whereby we have water scarce where there was drought. So in normal conditions it's like this. It's a convection circulation whereby rain will occur inland. Then during El Nino the rain will just occur in oceans. So it's like this is the El Nino part in the El Nino. But then there's also what we call La Nina, whereby there will be more rain on in the land. So that difference is of El Nino and La Nina. Now, why South Africa is special? South Africa is special place to study circulating ocean because South Africa is the only country whereby two oceans meet, whereby cold ocean and warm ocean meet, with the cold Benguela currents here, which is in Atlantic Ocean, we have also the warm Indian Ocean. They meet together. So South Africa is very special in studying ocean circulation. Now the key question that we covered in this talk is what is circulating ocean or ocean circulation, what are the driving forces of ocean circulation, also of which we have learned is that it is wind and this temperature, salinity. Yeah. Then what is the importance of ocean circulation, whereby we get the importance of this is upwelling, and also it regulates our weather patterns. Why is South Africa so special place to study ocean circulation? It is because, of course, South Africa is the only country whereby warm ocean meets with the cold ocean. Thank you. Questions?